Hello, everyone. D. Alfred Ostrowski here. This recording of Theory of Computation lectures. Our sixth lecture, I'm going to be covering Chomsky normal form. So this is differentiated from the Chomsky hierarchy. So this is a standardized format for grammars to support their management and implementation, both the Chomsky normal form as well as Greibeck normal forms allow for a standardized processing of grammars that enable them to be more amenable to implementation with any number of implementations, including compiler design. So working with these, there's really a dual benefit, right? That you have a additional comfort level of working with grammars and their substitutions and how they work, and as well as the means of standardizing their representation. So what is the Chomsky normal form and how do we get there? So Chomsky normal form says basically this: I need with a given grammar to have either two non-terminals in each production or a single terminal. And that's the format. It could be in the same role or different role. How do I get there? Okay. It's just simple substitution. So once you see it and you exercise it a few times, it shouldn't be difficult to comprehend. And again, the naming of the non-terminals, as long as you're using capital letters, is pretty inconsequential, right? It's just all about making the designation between non-terminals and terminals. So what wouldn't be in a Chomsky normal form would be a going to, let's say, ZZZ or BCA or AAA or AA or anything of that nature, right? It has to be whatever the representation is. It has to be going to two non-terminals, okay, or a single terminal. That's your Chomsky normal form. Pretty much it. Pretty cut and dry, okay? So let's just take some examples, and just like everything else in this, how do we get the comfort level working with it? It's all about just working through the examples and getting the exercise of doing the problems here. So let's take a simple grammar and convert it to Chomsky normal form. So I have two non-terminals and a terminal. First grammar rule, I have three terminals, and then I have a non-terminal followed by a terminal in my grammar. And I want to convert this to Chomsky normal form. It's the first thing that I want to do. First thing is I want to convert all my terminals that are not existing alone into non-terminals. Very simple. How do I convert a terminal into a non-terminal? If I have a simple terminal here and I wanted to make this represented as a non-terminal, even though this already fits into, right, our definition, I can express it as a non-terminal and have the non-terminal point to a terminal. So that is the means of substitution. Okay, that's basically what I'm going to be doing, and then substituting two non-terminals for a single non-terminal. I can do that as well. If I have S going to, let's say, AAA, and I want to make that two non-terminals, again, to fit this, fit our definitions I defined earlier, I can make this A1 and A1 go to AA, and I can say A1A, and there you go. So I was able to convert this in from three non-terminals or n non-terminals into two non-terminals. So this is the mechanics that we do to apply this, okay, to get our Chomsky normal form. So let's do this, okay? So back to our problem, okay? I'm going to take A, B, and the terminal A is a problem. It can't exist with the non-terminals. So I'm going to take wherever A is, I'm going to re-express this as, let's just call it A1, okay, for convenience. I could name it anything, right? Whatever you do, it's important, whatever conventions you follow is to be consistent, right? That way you won't make any mistakes. So here I have 3 non-terminals. I've got rid of that, and I want it to be consistent. So I'm going to name this A1, A1, B, and I'm going to say my B, A, C, and I have A1 point to terminal A. So this already is in Chomsky normal form, right? Because it follows our convention. I'm going to do this with B and C, and I can do that in one fell swoop since we know what we're doing already, right? So I can say A, B, A1, don't forget the 1. I'm going to say A, A1, A1. I'm going to call this non-terminal B1. And I'm going to write this down here so I don't forget, right? So the non-terminal B1 goes to B, and that's just following the non-terminal A going to the A terminal, right? Now B, and I can follow through here and have a C1 going to C. There we go. Almost done. Have we fit the criterion for Chomsky normal form? Well, we're close, right? These are all in our constructs. B is all set, but I got a problem here, right? I got a problem that ABA is 3, I need 2. So I can say A2. Okay, I can just re-express this. I can say A2, A1, and I can write down here A2 is AB. I could have just done BA, it doesn't matter. I could do either one. There's no exacting rules around that. And then finally I can say, put an A3 here, B, and A3 is going to A1, A1. And B points to a C1, and then I can just carry over as I have before. I can put the A1 to A, B1, B, and C1 to terminal C. Let's see what we got. Okay, I have S going to 2 non-terminals. Very good. A goes to A3, B, 2 non-terminals. B goes to A, C1, 2 non-terminals. A goes to 1 terminal, B goes to terminal, C goes to terminal. A goes to non-terminal AB, A3 goes to non-terminal A1, A1. There you go. So we are in Chomsky normal form. And that's it, pretty straightforward. So first thing, convert all your terminals to non-terminals, the ones that are existing with non-terminals, okay, the ones that were identified here, and here were the problem areas. This one was as well as this one, right? And make them assigned as non-terminals. And then the final transition is reduce the number of non-terminals from 3 or more, any number, to 2. There you go. Pretty straightforward. And once you get a comfort level with this, a couple of these, and then we can work on the Greiback normal form, which is not much more complicated, but it is more involved, a number of further steps. But just like everything else, it's a function of practice. And once you go through it, I'm sure that you'll pick it up. Thanks for listening. Hope this helps. If you have any issues, feel free to contact me. Thank you.